Okay, so today we are going to talk about the applications of determinants. Okay, um, Mr. Votek did talk to you about Kramer's rule a little bit. I'm going to just talk about it again in case some of you zoned out. We did it last week. You didn't do any homework on it, so I'm going to talk about it again. Okay? So first of all, Kramer's rule is another way to solve a system of linear equations. So that worksheet that I gave you on Friday, on the cafeteria side, you guys use matrix equations to solve them. Maybe you did row echelon form to solve them. We also know back from chapter 7, we use substitution and elimination to solve them. Back in algebra 2, you use graphing to solve them. Now here is yet another way to solve them. Okay, Kramer's rule, which is the use of determinants of a matrix to solve them. Okay. So this is how it's going to work. We're going to solve each variable the same way. Okay, all with determinants. Okay, it's going to be a fraction of 2 determinants. Okay. We obviously can't do this if the determinant is 0, okay, because we'd be dividing by 0. So this is what it's going to look like for each variable. All right, so I'm going to talk about x, and then the same thing's going to happen for y, z, however many variables you have. So we're going to have a determinant divided by a determinant. That's why I have the letter D up there. Now I have a little symbol right here with an x, the determinant with a little x subscript. Okay, what does that mean? First of all, the determinant downstairs, that is going to be the coefficient matrix. Okay, so you take all the coefficients from your variables, x, y, z, whatever, and that's going to be the matrix you use in the denominator for all of your variables. Okay. Now, in this case, we're solving for x, so in our numerator, that determinant is going to come from the matrix. We're going to take our coefficient matrix, and since we're solving for x, we're going to replace the x column with the constant. Okay? So I'll have you write it down, and I will explain what I mean by that. Okay, so first of all, what would be my coefficient matrix for this system? How do we get the coefficient matrix? Coefficients. What are coefficients? The numbers in front of the letters, okay? So our coefficient matrix is 1, 2, -6, 5. Okay? The determinant of the coefficient matrix is always going to be in your denominator. Okay? Now, if you are solving for x, then in your numerator, you're going to have the determinant of the coefficient matrix, except you're going to replace a column. Okay? Since we're solving for x, notice how each column represents a different variable. This first column is our x coefficients. This second column is our y coefficients. Are you with me? Okay? Since we're solving for x, we're going to replace the x column. Okay, so we're going to have the same coefficients for y, but instead of writing our x coefficients, we're going to write these constants on the other side of the equal sign. Okay? When you find a determinant, do you get a matrix or do you get a number? You get a number, okay? So when we take the determinants, we're going to get a fraction that's an actual number, and that'll give us our x value. Okay? Now, if I want to solve for y, we're going to do the same thing, but in our numerator, we're going to take this coefficient matrix, and instead of replacing the x values, we're going to place the y values with this 3 and 10. Questions? Okay. We are going to do a 3-system example. 3-variable example. So if we are going to use Cramer's rule, we know we're going to have a fraction for each of our variables. Okay, in the denominator, what do we put there? Which matrix? What? The coefficient matrix. So the coefficients are -1, 2, -3. What about the second row? What would that be? 2, 0, 1. And then 3, -4, 4. That's the coefficient matrix, but we want its determinant, right? Okay. And then upstairs, we're going to take that same matrix, but what is going to be different? The x column is going to be what? 1, 0, 2, because those are our constants over on the right side. Okay, now we have to find 2 determinants. Okay, a 3-by-3 determinant, is it hard to find? No. Takes a little bit of work, but is it hard? Okay, we're not going to use our calculator. We don't need to use our calculator. We can do this by hand, right? How do we do a 3-by-3 determinant by hand? Okay, we need to find the diagonals, right? Okay, which diagonals do we do first?
Downwards.
Okay, so 1 times 0 times 4. 2 times 1 times 2. -3 times, it doesn't matter, it's going to be 0, right? Minus 2 times 0 times -3. -4 times 1 times 1. And 0. Okay? So what is the value of our numerator? Eight?
Negative.
Well, if it's the negative, make it
Oh, wait.
positive 4, 16 plus 4. Oh, 14 plus 4. Good, once you get it to 0.
0 plus 4 plus
Oh, I thought
0.
that was a 10 plus 4.
It definitely looks like a 10,
Yeah.
but I just come up with these laws.
My math's still a bit wrong. Oh,
Okay, Joey. Are we okay with 8 now? Okay. Do the denominator. Alright. So our diagonals. -1 times 0 times 4. Better, Joey? 2 times 1 times 3. Plus this diagonal. Minus this one. Good. Here. And here. So what is our denominator? 10? Okay. And so then we can reduce that to 4/5, right? We'll reduce that later. All right, so we found x. Now we need to find y. Now, before you start complaining, we're going to have a fraction, right? What's in the denominator? The same thing. In all of our denominators, it's going to be the determinant of the coefficient matrix. That's not going to change. So we know it's going to be 10. Okay? Now we just have to change our numerator. All right? In our numerator, we have the coefficient matrix, except what's going to be different. The y column is going to change to the 1, 0, 2. Our x's are going to stay as -1, 2, 3. Our z's are going to stay as -3, 1, 4. Okay. Before we figure out what that is, let's talk about z. Our z value, we know the denominator is going to be 10 as well, right? And then in the numerator, the coefficient matrix, we're going to change the z column to the 1, 0, 2. And the x's and y's should stay the same. Okay? We're going to break up the work a little bit, though. I want prods 1, 2, and 3 to find me the numerator for y. I want prods 4, 5, and 6 to find me the numerator for z. By hand. What's our y numerator? Just the determinant. Don't give me anything simplified. Negative 15. Pods 1, 2, and 3. Do you agree with Josh? All right, Joe, you reading your math?
Yeah.
Okay. Pods 4, 5, and 6. Our z numerator. Negative 16. Do you agree? Let's talk about your diagonals. Oh, you guys are good now? Okay. Now, what was our goal with all of this? Why did we do this? To solve our system of equations, right? And when we solve a system of equations, what's our answer? A coordinate. So our x was 8/10, so I'm going to write 4/5. Our y value was negative 15/10, so negative 3/2. And our z value was negative 16/10, so negative 8/5. This is your answer. Now, in chapter 7, you solved these by elimination. With this solution, would that have been very much fun? That would have been a pain, correct? All those fractions. Okay, so as much, I know you guys are thinking, oh my gosh, 4 determinants I have to find, that is ridiculous. This is a much quicker way than if we had to solve this particular one by elimination because of those awful fractions that we would have had to be substituting back in. Okay, so yes, 4 determinants that are 3 by 3 kind of seems like a lot, but is it hard? No, it's just a little monotonous, but it's an easy way to solve. Okay, and the nice thing is our denominator is the same. So even though we have 6 determinants to find, 3 are the same, so you really only have to find 4. Okay? Do we feel okay about Cramer's rule? Yeah? Okay. You will have to do these for 2 by 2 and 3 by 3. 2 by 2 will obviously go a lot quicker, but you'll have to do them for both. Okay? Let's look at a few other things we can do with determinants. The first thing is we can find the area of a triangle. Okay. If we have 3 coordinates, we can make, first of all, we can make a triangle. Okay. We can put them into this formula to find the area of that triangle. Now, I see a plus or minus right here. Does anybody know why there's that plus or minus there? Or why would it make sense that we have that plus or minus there? Any ideas? You're on the right track. First of all, area has to be what? Area better be positive, right? Is it possible to get a negative value for a determinant? Yes. Okay? But area needs to be positive. So if your determinant ends up being negative, then you need to use the negative 1/2, so you get a positive area. If your determinant is positive, then you need to use the positive 1/2, so you get a positive area. Okay? Now, it doesn't really matter in what order the coordinates are put into your matrix, as long as you have the coordinate xy with a 1, xy with a 1, okay? So the x and y that are in the same row need to be from the same coordinates, okay? And then you fill in your third column with a 1, okay? Questions on how that's set up? So here we go. I want to find the area of a triangle with vertices 1, 0, 2, 2, and 4, 3. We don't need it. Because what do these bars mean that need determinant, right? We already talked about that. 3 by 3 determinant, we don't need a calculator for. Okay? So our area plus or minus 1/2 will decide which one we need after we find the determinant. Okay? I don't care which coordinate you pick from first, you're going to get the same determinant, either positive or negative, and since the sign doesn't matter, we're going to be fine. So, I'm going to put 1, 0 with a 1, coordinate 2, 2 with a 1, and then coordinate 4, 3 with a 1. We at least have 1, 0 in our determinant, so that's going to make it a little bit easier, right? Okay. So, let's go ahead and evaluate our determinant. Okay. So, first set of diagonals, what do we get here? We get 2 plus 0 plus 6. Right? Minus, what do we get here? What do we get here? Thank you. Plus. So we have 8 minus 11, which is -3. Alright? So do we need the positive or the negative 1/2? We need the negative 1/2. So our area is 3/2 square units. We're talking about area, so we know it's going to be square units, right? Okay. Now, I want to go back to this. This is the area of a triangle, correct? Does anybody have an idea of what it would mean if this determinant would end up being 0? Any ideas? What does collinear mean? Okay, if a triangle is formed, those 3 points cannot make a line, right? Okay. If this determinant ends up being 0, we do not have a triangle. We have points that lie on the same line, which is called collinear. Okay? So write this down. If this determinant is 0, then we know that the 3 coordinates lie on the same line. They are collinear. So if I were to ask you, are these 3 points collinear? All you're gonna have to do is find this determinant with these ones in the third column. If it's 0, yes, they are collinear. If it's not 0, no, they are not collinear. We can find the area of that triangle. So let's try it with these. Are these 3 points collinear? Okay, so we have -2, 1, 1, and 7, 5. Okay, so here's that determinant with our coordinates. Coordinate 1, coordinate 1, coordinate 1. Okay, we need to find its determinant. Alright, so here we go. Help me out. This diagonal. This diagonal. This diagonal. Okay, we're going to add those together and subtract the up diagonals. Here we go with 7 and okay. So what does that give us? These three numbers give us what? -11. Okay. Minus. Minus -5. Is that 0? No, these are not collinear points. Do not forget to answer the question. Is it not what +5?
Yeah, but it's minus.
Sorry,
It's
it's
still
minus,
low.
it's -5. Every time.
Either way, it's still no.
It's minus and
So we
then
plus 5.
Oh, yeah, I got a lot.
Right.
7 minus 6 is minus 3. Minus 2 is minus 1. 6 for the addition.
Yeah, okay, wait.
We're okay with minus -5.
Yes.
Yeah.
Okay.
Yes.
Joey, you good?
Yeah.
Okay. Last thing. Now, what we can do, all right, what can we do with 2 points in a plane?
line.
We can make a line. And in algebra, if we have 2 points, can we write the equation of a line? Yes. Okay. What we're going to do is we are going to write the equation of a line using this knowledge right here. Okay. If we have 3 points that make a line, when we put them into this determinant, that determinant is 0, correct? So if we know 2 points, okay, we can just make a generic XY coordinate to plug into that matrix, okay? We know that this determinant is going to be 0, and by solving this determinant, we can actually write the equation of the line. So we have 2 points. We're going to make a generic XY. We know if it's a line, this determinant is going to be 0. So we're going to solve it out, and we're actually going to get the equation of the line. Are you ready? Okay, last example. Yay. Okay, so I have a point 2, 4, and negative 1, 3. We are going to write the equation of the line using a matrix. I know all of you can do this with finding slope and whatnot. Okay, we're going to use a matrix though. Okay, so here are my 2 points. I'm going to put in a generic x, y coordinate. Okay, that way we're actually going to have an equation with variables. There's our 2 variables. Okay, we have the coordinate 2, 4, and we have the coordinate negative 1, 3. We know that this better equal 0 because it's a line. Alright, so we're going to go ahead and find the determinant. Yes, I know we have variables. That's going to be okay. Alright, still going to be the same process. We're going to repeat our 2 columns over here. Okay, and we're going to take our diagonals to find our determinant. Okay, so our first set of diagonals, we have x times 4 times 1 to get 4x. Y times 1 times negative 1. Negative y, and 1 times 2 times 3. Okay, minus our up diagonals, negative 1 times 4 times 1, plus 3 times 1 times x, plus 1 times 2 times y. And we know that has to equal 0. Okay? The equation of a line is what we're going for here. Now we have x's, y's, and constants. So let's go ahead and combine like terms. We have 4x minus 3x gives us x. We have negative y minus 2y. And then we have 6 minus negative 4. 10. Okay? Let's go ahead and make this look like the equation of a line. Okay? X minus 3y equals negative 10. What form is this? This is standard form. That is just fine. Okay? It's the equation of a line. So, okay? Any questions there? Okay? Do not use a calculator to find your determinant on this assignment. Okay? First of all, it'll be good practice for you. Okay? By the end of it, you're going to be professionals at finding 3 by 3 determinants.